All right. Wow. Thank you guys for coming. This is just absolutely incredible. All right. I'm going to talk about something we call Weave. But what is Weave? Weave is a powerful compositional toolkit for ML practitioners. So I hope that answered the question. Okay, it probably didn't. But before we talk about what Weave is today, we're going to go back and talk about what Weave was. It all started with Weave.js, or JavaScript. So back in 2020, we had just built this thing called Artifacts, our tool for versioning unstructured data on top of object stores and tracking all its lineage. But people started saying, okay, cool, I put all my data in there, but you guys make analysis tools, so how can I see my data? So we built Weave. We originally built it with the goal of helping people organize and understand model evaluations. It lets you easily see the results of large-scale analysis while tracking the individual computations and examples that make it up. Our customers use Weave to understand their models in context. This is a screenshot from a case study by Woven Toyota about how they use Weave in their core model evaluation processes. The Weave UI is built from some really cool technology with the unique goal of making a truly programmable UI. Any Weave UI component can expose Weave expressions, which themselves are compositions of Weave ops, directly to the user. Why do we call it Weave? Because the Weave rendering engine weaves a compute graph through the UI. This means any value displayed by the UI, we can ask, how is this value computed? Enabling powerful faceting, drill down, and comparison capabilities. This gives Weave more expressiveness than other UIs while remaining highly visual. And we've only just scratched the surface of what we can do with this. Weave is built on a powerful type system, comparable to the ones found in Python and TypeScript. This lets us suggest the right operations in the right place, and at any place a visualization can be used, users can choose the one that makes the most sense for their data. In other words, we design Weave so that at any given point, we can present you the right options in an intuitive way. And it powers a lot of W&B today, from tables, our tool for data understanding, to the UI for our model registry that Carrie just showed, and the browser for W&B artifacts. And because of Weave, we can ship new stuff really quickly. One of the Weave engineers, Tim, took a quick weekend break from building Weave to ship our new trace visualizer a couple months ago. It's pretty magical, but there are a few limitations. Weave executes entirely in the browser. This means it has to download all of your data to your machine before it can be processed. So if you uploaded a 500 megabyte table, yeah, we download that whole thing into your browser on every single page load. Weave has a really powerful extension model, but only we at Weights and Biases can use it to make cool stuff. And it's not implemented in the language that our users use the most. So what did we do? Well, we're excited to announce Weave Python, which we now just call Weave. Thank you. We built Weave from the ground up on top of Apache Arrow. It has a vectorizing DAG execution engine for performance and scale and a first-class Python API. Now, when we first built Weights and Biases back in 2017, we had an open source Python client and a closed backend. Lucas, Chris, and I made multiple attempts at open sourcing larger parts of it, but none of them saw the light of day. And I'm here to tell you, it is hard to open something that starts off closed. So I'm very proud to announce that as of today, Weave is free and open source. And I really mean open source with a permissive Apache 2 license. And now I get to show it to you. First, one question for the audience. How many people here use notebooks like Jupyter notebooks every week? Pretty good, pretty good. For the rest of you, you might want to, okay, you can stay, but this is going to get pretty nerdy. Cool. Okay, so Weave is notebook first. And I'm going to show the demo, but just let me give a little setup. We built a question answer bot that runs in our Discord channel that can answer questions about weights and biases based on our docs. It's built with LangChain and the Face Vector Store and ChatGPT. Hopefully all of you have made one of these by now. It's like really easy to do. And in this first demo, we're going to take a look at how a data set that came from evaluating our doc bot with 3 different prompt templates. Cool. Okay. So here we are in a Jupyter notebook. And this is the default, familiar default pandas data frame visualization. So you can see the first few rows and the last few rows, and the first few columns and the last few columns. But you can't do much more than that. So let's see how this looks in Weave. First, we convert the data to Weave. You can go back and forth between pandas and Weave really easily. Then we save it to give it a name and start versioning it. And now we see the Weave UI. You can click to the end to see the tail of the data, go back to the beginning, change the row height to get a better view. And you can expand large values with this cool hover state. Now let's do some checks on this data. I see there are 3 token columns here: token counts, prompt tokens, completion tokens, and total tokens. And I think that the prompt and completion tokens should add up to total, but let's check. So we can add a Weave expression here to add those 2 columns together. And yeah, the first few rows at least seem to match. Let's make sure everything matches. We can add a Boolean operation to make the comparison. So now we see these rows are true. We can sort up and down to make sure that both ends are true. Or we can group by this column and make sure there's just one row in the result. Let's see. There we go, just one row. So it looks like everything matches. Great. Okay, so now let's actually compare the 3 prompt templates that we evaluated here. We'll go over to the right and group by the prompt template to get one row for each. Under grouping in Weave, scalar columns become lists of scalars. And by default, Weave chooses the histogram panel for lists of numbers. But we can choose another one, like the list of number panel, which gives us a little pager so we can see the individual values. We can also change the Weave expression to do a new operation here. So we'll ask for the average. And we can see that the few-shot model actually was more expensive by token costs, which makes sense. What else can we find? Well, if we scroll over to the synth grader column, we can see that the default LangChain model actually had a better ratio of negative feedback. So it looks like the default LangChain model is better on both the cost axis and the performance axis. So we should probably just use that. So Weave is designed to make it incredibly easy to iteratively ask questions of your data and give you the right operations and visualizations just as you need them. And it takes the meaning of composition to a new level. So let me show you. Okay, so for an analysis like this, it's really useful to compare models across the same input. For example, we can look for questions that all the models struggled with, or questions where some models were right and some were wrong. To do that in Weave, we'll group by the question column. Now, it seems like we have a problem. The number of grouped rows is about the same as the number of ungrouped rows, so I'm not sure that we actually asked the models the same question. We can continue to edit the table to count these groups. And we can see the counts, but we actually want a count of those counts to finish this analysis. How can we do it? Well, we can go to the right in this cool little drawer and click the plus icon to add a new panel. And we can refer to the first panel from the second one to ask for its values. So now we see the data from the first table mirrored in the second, and we can do further operations from here. We can group by that second count column, count that, and finally we have our answer. There are only 32 questions that 2 or more models actually answered, so we can't actually do the analysis that we want here. So one of the major goals of Weave is that you never hit a dead end and never feel boxed in. Composing panels together in the way we just showed is just one of the many ways that we achieve that. What other types of visualizations can we do? Well, of course, plots are pretty useful. And Weave has an incredibly powerful one built in. You can add all kinds of layers and dimensions. But for now, we'll keep it simple. So we'll change the panel type here to plot, and then edit its configuration. We'll look at latency versus cost, and we'll color by prompt version. Cool. We can see some outliers here on the latency axis. That's pretty common when you're working with LLM APIs. And we can see some other outliers on the cost axis that might be interesting. But first, we'll zoom into this big group here to get a better view. Yeah, and again, we can see the distribution of latencies pretty well. We'll make the point size a little smaller to get more space. That looks good. We can see the few-shot model truly is more expensive than the others. Let's zoom back out. And now, let's look at those cost outliers. So the default Weave tooltip doesn't actually show you the underlying data. It shows you the plot values, but we can edit it. Here we put a dictionary in the prompt in the tooltip. And now we can render the actual question and answer from the underlying data. So we can see here, this was asking how to plot stuff with weights and biases, and we answered to use scikit-learn. That doesn't seem right. Cool. So this was another example of how powerful composition is in Weave. Any panel can expose expressions and panel choices. Here, the Weave plot tooltip gave us complete control over how we viewed our data. And now we'll start to break out of the Jupyter Notebook to show you something brand new, the Weave board. This is a new kind of truly programmable UI, and we're only just starting to figure out ourselves what this powerful tool can do. I hope you like it. So in the last demo, we showed a way to drill down on a single point in a plot. Let's look at another type of drill down you can do in Weave. Starting from the table, we'll add a new panel. And we'll refer to the first panel again, this time asking for active data. Now we have a view of a single row on the right. So we can click on the row index on the left to select a new row. This is a nice drill down, a way to see more details about our data. But we're starting to run out of space in the notebook. Let's click the full screen button. Now we're in the Weave UI, and we can see our data in all its glory. And from here, we can convert to a Weave board. The Weave board has a special area on the left for storing variables, expressions, and controls that we affectionately call the var bar. Someone internally was saying if we have a bar at the conference, we should call it the var bar. Not sure if we did that, but that would be awesome. So you can also lay things out as you want. We're reorganizing the board here. And now we're going to add a different type of visualization. So our data set contains synthetic evaluation results for each of the QA pairs. Let's get a view of how each model did across those evaluations. We do it using the facet panel. So we're setting the X dimension to the prompt version and the Y dimension to the synthetic grader response. And then we'll set the cell to show the count of the intersection. Awesome. Now down here we can see the counts of how each model did. But it's kind of hard to read numbers like this, so let's add some color. We split the panel into two, convert one of them into a color panel, change that to a layer, and normalize the data a little bit by manipulating the Weave expression. Now we have a nice looking, almost confusion matrix of our data. Still, we want to see the individual examples every time we do something like this, so we want to drill down. We can click a cell here and then refer to the selected state on the left, so that now when we pick a cell in the confusion matrix, we can see the actual examples that make it up. Here the grader dinged the response for not including enough detail, which seems fair in this case. Okay, we're going to add one more visualization, a distribution. And for this, we'll use a distribution plot, so we can compare latencies across models. There we go. But there's a problem here. Our data is not actually showing up, and it's cut off at the bottom of the screen. But if we could see the x-axis, we would see that it looks like the data axis is extended way far out, so there must be outliers pulling it out. So we can come up here and add a new Weave expression to filter that data out of the data set. We'll give that expression a nice variable name. And then we can refer to it in this plot. Cool. There's the data. Now let's just change the bin size to make it a little finer grained. And it looks like we've cut the data off with our filter. So we'll go back up and extend the filter. And now we have what we want to see. So a great next step from here would be to normalize the latency distributions using the var bar to get a fair comparison. Okay, the Weave board is super cool. It's a powerful new tool, a WYSIWYG UI for programmers, and we're only just scratching the surface of what it can do. Now, before we leave, did you notice the publish button earlier in the upper right-hand corner? You can publish anything you do in Weave to weights and biases. Published Weave objects are stored in W&B artifacts. You can see all your published objects, dashboards, and objects at weave.w&b.ai and use them in W&B workspaces and reports. And you can share anything with your team or the world. Okay, now let's talk about the Weave ecosystem. We're just getting started with the ecosystem, and you can find all of our experiments in the Weave ecosystem folder in the repo. I'm going to explain this a little bit because this goes by super fast. So we're first going to show how easy it is to render other data types in Weave. We'll create a list of dictionaries that have some pill images in them. And when we run that top cell, we'll get a familiar with Weave table with the images in line. If we want to add a new operation, we'll run the third cell. It's very blurry. There's code in there that creates a Weave op, and then we call it from the UI. So here's our table with images in it. We run the cell below, and now we can add a new column that uses that operation to flip the image from left to right. Super easy. Next, we're going to show how Weave seamlessly integrates different libraries from the community. So here we'll use our Hugging Face integration to load an emotion classifier model. The model shows the model card, the panel shows the model card by default, but we can also call the model. So we're going to call it with the string I'm in love. And we can see that the model actually classifies love as mostly anger and joy, which is surprising to us. Why is it doing that? So we can ask for the attention that was paid off of this model, and we get a new view that's registered called the BertViz head view from a different library in the ecosystem. This is a little interactive visualization for understanding attention. But I still can't really tell what's going on here, so let's try another one. We'll use the SHAP explain op to get SHAP values that maybe will give us another view. So this will render a SHAP visualization where we can hover over the words in our input to see where the attention was paid. And we can see when we hover over anger, it's actually paying attention to the exclamation point. So maybe if we remove that, we'll get something better. Yeah. Now the model mostly classifies love as love, and just the right amount of anger to keep things interesting. Yeah. Model understanding and explainability are becoming more and more important as models get larger and more powerful. Weave's type dispatch system means that anyone can publish a new explainability technique and make it available to everyone else who has the right type of data. This is one of the primary reasons Weave is designed the way it is, and I hope it helps the community in the work needed to understand these models at a fundamental level. Okay, now we're standing on the shoulders of giants with everything we do, but this is all the Weave code we needed for that BertViz visualization. We register a new Weave op that takes the Hugging Face attention and returns some HTML using the BertViz library. And then we register a panel that will render that in the right context. That's all you have to do. Okay. Thank you, thank you. And now we're going to show 3 small applications we've made that put all this stuff together. You can find each one of these in the examples directory in the Weave repo. And the first one I'll show is actually kind of a toy, but I really want to say something about this. Making stuff fun to play with is a really important part of product development for us. It's why we spend so much time on making it feel nice to resize panels in W&B workspaces, or why the W&B logo animates when you hover over it. Play and experimentation are closely related. You need to play with these models to understand how they work and make use of them. So crossing the threshold of fun in Weave boards was a huge moment for us. So this is a Weave board that uses a language model to generate a storyboard for a film, and then uses Stable Diffusion to render each panel in the storyboard. Here we generated a storyboard about a rollerblading documentary by Wes Anderson who's feeling worldly. And you can change any of the parameters, prompts, or structures by editing the varbar. I want to call your attention to one thing as we click through here. We asked the chat model to output the storyline as a JSON list structure, and then we just parse the JSON list using a Weave op. So the format of that JSON list that actually comes out in this UI changes from run to run. So you'll see that table on the top shift around if you come play with this thing. You'll have all different columns. It just depends on what GPT decided to do. So essentially, we're letting the model generate the Weave UI here, and I just think that's like super cool. This next one is an evaluation playground we use for the docbot we talked about earlier. So this makes use of our integration with the awesome LangChain library you'll hear about later. And in the varbar, we've configured the entire pipeline for 2 models. We load our documents and questions from Weave objects, create a vector store, create 2 different models or chains for comparison, and you can add new questions or documents by saving new versions of Weave objects. And soon you'll be able to edit the data right here in the UI. Weave's powerful memoization model means that we'll only recompute what's necessary whenever parameters change. So if you add new questions to the list, it'll just make 2 new LLM API calls. So here we are clicking through the varbar to see how it's configured. At the top, we can test our model with new questions, so we can ask whatever we want here and see new results. We can compare the model outputs and see other stats like latency. And we can click down to view traces of the LangChain executions using the W&B trace viewer. The next table lets us explore inference results across all the questions we loaded in. Here we're comparing 10 negative and positively reviewed responses. We can drill down on a projection of the docs in our vector store here, and we can see that that pink cluster is mostly the Weave documentation. And we can do similarity searches on the vector store to help us understand it better. So Weave boards are a fantastic way to do prompt engineering and build LLM applications. You can build up a set of helpful visualizations and tools that are unique to the specific problem you're trying to solve. Okay, now, this last application is incredibly important. People have been asking me to do this for a very long time. So I'm proud to say that today, we're launching production monitoring. You can log production data to weights and biases with a few lines of code and get beautiful Weave dashboards that you can customize to your use case. We'll take a quick look at a production monitoring dashboard for a completion model we've been running since January. So on the top, we can see the count of predictions we've made for each model version. And on the right, we can see the count of predictions we've made for each user. Below, we'd have different views on API cost, token count, and latency. And at the bottom, we have a table of all the records that are displayed in the dashboard. We can edit the time range to zoom out. Soon we'll add a date picker control, so you can use that if you'd rather have something visual. And we can see that our service has been steadily growing as we've continued to add new model versions. Awesome. You can click on items in the table to drill down, or use the controls in the sidebar. So let's filter down to model version 1.4. The whole dashboard updates to this slice, and we can see that we ran this particular version between January and February. We had a lot less usage back then. So all of this is totally configurable in Weave, from the way the charts do their aggregations to the exact setup details of the varbar. So that was a really, really quick look at production monitoring with weights and biases in Weave. We'll be providing, out of the box, starting dashboards for different problem domains. But as you learn about the problems you're trying to solve, you can add new views, capabilities, and techniques by taking advantage of the growing Weave ecosystem or extending Weave with those 3 simple primitives. So that's Weave. Now, I've been working on this for a very long time. And actually, it's these folks who have been working on Weave for a very long time. So, we're like really lucky that we get to work in this space with customers and users like all of you on problems that we love. But there's been a massive amount of blood, sweat, and tears poured into making this happen. And I'm so proud of this team and everyone else at W&B for the work that they do. So thank you. We focused on the details from the inside out to enable the next generation of ML apps and tooling. It's early, there are sharp edges and gotchas, but the system is also incredibly powerful and fun, and I couldn't be more excited to put it in your hands. So go out and try Weave, or go to the link above to get in touch with us about production monitoring, and thank you all very much.